going to discuss about MATLAB script file, or also known as M file. So to create a script file, you can click here to create a new script. By clicking here, an editor will be opened where you can type your script here. You can also click here and choose new script. The same will happen. Or you can also type edit space the name of the script, for example test, and when you press enter, a new file test.m will be created in your current folder, and this is where you type in your script. So let's say we want to create an average. So say we have game 1 that is equal to 10, the score, and we put semicolon. If you do not put semicolon, MATLAB will give a warning. It says terminate statement with semicolon to suppress output within a script. So we can either put semicolon to make this warning goes away, or you can simply click on fix, then a semicolon will appear here. Then let's say we have the score for game 2, that is 50, and also we have the score for game 3 that is equal to 30, for example. Now what we want to do is we want to calculate the average that is equal to game 1 plus game 2 plus game 3, and everything will be divided by 3. So we can then execute the script by clicking the run button here. You can click the run button and MATLAB says test has been executed, and all the values appear here in the workspace. So we have game 1 equals to 10, game 2 equals to 50, game 3 equals to 30, and the average of this is 30. If we exclude the semicolon and click run again, MATLAB will display the average value here that is equal to 30. Another method to run a script is by typing its name. So if we type in test, then MATLAB will read the test.m file within the current folder, and this will generate the answer of 30. Okay, another method that we can do is, instead of we define here in all the values in the script, we can use a command called input. So I will change 10 here to input, and then we use a square bracket, and you can put an instruction. For example, we type in please input the value for game 1. We put like this, and we close in the bracket, and I will copy this and do the same for game 2. We change this to game 2, and we do this also for game number 3. So when we execute the script now, or the M file, now MATLAB asks what is the input for game 1. So we say game 1 equals to 10. Now what is the input for game 2? We say this is equal to 50, and the input for game 3, that is equal to 30. And then MATLAB will execute the average command, or the average calculation here, and it shows that the average is equal to 30. Now we go to the output command. We can generate output by using two commands. The first one is disp. So let's look at disp command first. Okay, so what we have here is that when MATLAB has calculated the average, now I don't want MATLAB to display this average, but I want MATLAB to display in a better way. So we use a disp command, disp, and within a round bracket, we type in the strings. So the average of points scored in the game is, okay, remember from our previous lesson that for strings you have to type the strings within the asterisk or apostrophe symbol. So this is the strings, and then we put another disp, and what we want to display now is the average. The average here refers to the variable that we have created up here. So now when we run the script, now MATLAB will ask the input of game 1, say this is 10, this is 50 for game 2 and 30 for game 3. When we press enter, MATLAB display this command. The average of points scored in the game is, and then it returns the value of the calculated variables average here. So this is one way to output something from MATLAB calculation in a better way, in a nicer way. Okay, next we proceed to the next output command, that is fprintf. So instead of using disp command, we can also use the fprintf command. So I'm going to show you how to use the fprintf command. So the command is fprintf. In order for us to include the value, now we need to use the percent symbol and then f for the fixed point notation. I will show you what this will produce after this. And then after the strings, after we close the string with apostrophe symbol, we need to put a comma, and then we type in what is the variable. In this case, our variable is avg, so we type in here avg. So when we press run, we will get the average of points scored in the game is this. So this %f here will produce this result, 30.6133. We can change how MATLAB displays the result by changing this number f into, for example, if we type in e, this will produce in scientific format, so e to the power of 1. If we type in capital E, the small e will change into capital E. We can also type in, for example, G. This will give us a shorter answer up to 4 decimal places. And we can also type in I for integer. For example, this will give you 3.06 e to the power of 1. Normally, we just use the f notation, fixed point notation, and then we can have more of the, this is required. This is the required syntax that need to be written in order for you to use the fprintf command. But the other optional function is, for example, we can type in minus. Minus here will produce left justified number. Okay, so if we include minus f, we press run, it will produce the same thing, is left justified. If we put plus symbol, then it will print out whether this is positive or negative. If it is positive, then it will say plus 30 point something. If it is negative, then it will show also negative. So normally we do not use this plus symbol. And then we can also include the precision. For example, how many digits we want to display. Let's say I want to display only 4 digits, so I include 4 point and then followed by how many decimal places. For example, I just want 2 decimal places. Then when I press run, I will get 30.61. So it is 4 digits with 2 decimal places. So let's say I want 4 decimal places. I change this to 4 and I will get 30.6133. Okay, if I say 1, then I will get only 1 decimal places. That is the use of fprintf. And there is another function for fprintf That is, we can add a new line. For example, if we want to say the average of points scored in the game is, and we want the value to go to the next line, so we type in \n. When we press run, you see that 30.6 is now going down. And normally we want also to type in \n at the end, so that our next line will go down there. So we have the average of points scored in the game is 30.6. We can bring 30.6 down here by using the \n function in fprintf command. Okay, so here is another example of using the fprintf command. Now we have this program here. This program calculates the distance of a projectile given its initial velocity. So we define v is equal to 1584 initial velocity in kilometer per hour, and the angle that the projectile was shot, that is 30 degrees. Angle theta is 30 degrees. And then we change the velocity from kilometer per hour to meter per second by calculating VMS, or velocity in meter per second, that is equal to V times 1000 divided by 3600. This will transform the velocity in kilometer per hour into meter per second unit. Then we'll calculate the time taken, that is the velocity in meter per second times sine of 30 degrees divided by 9.81. And then we calculate the distance, that is v velocity in meter per second times cos of 30 degrees times 2 times t divided by 1000. So what I want to show here is that we can use the fprintf command to print more than one variable, to display more than one variable. For example, here we have a sentence, a projectile shot at, now this is the first variable, percent 3 digits 2 decimal places f, degrees, with a velocity of now this is the second variable, percent 4 digits 2 decimal places, in kilometer per hour, will travel a distance of, now this is percent g, kilometer. So see, we have three variables here. The first one represents the theta, the angle. So after the strings, we put comma theta, the first. This refers to the theta here, refer to the first variable. Now v is the velocity, refer to the second variable here, and finally the distance refer to the third variable. So we can display three variables at the same time, or more than one variables at the same time, using the fprintf command. So when we press run, this will be displayed, a projectile shot at 30 degrees. Now you see we want three digits with 2 decimal places, so it is 30, so it will be printed as 30.00 degrees with a velocity of 4 digits 0.2 decimal places. So we have 4 digits in front, 1584.00, because we specify here 2 decimal places, will travel a distance of g. Now we want this in g stands for 5 digits in total, so we have 17.091 kilometer. So this is how we can use the fprintf command to print or to display more than one variable. The fprintf command is vectorized, which means that a variable that is a vector or a matrix that is included in the command will repeat itself until all elements are displayed. For example, let's say we have here a vector x from 1 until 5, and we calculate the square root of we calculate y that is equal to the square root of x, and then we have a matrix T that lists all the values of x and all the values of y, which is the square root of each value of x. Now this command fprintf here will be produced for every values in the matrix or in the array. Let's run this command and see how it goes. So when I press run, MATLAB will say x equal to 1, y equals to 1. When x is equal to 2, y is equal to 1.4142. When x equals to 3, y is equal to 1.73. X equals 4, y equals to 2, x equals 5, y equals to 2.2361. So the fprintf command, this command will produce a space, a white space here, and this here will print this, and you see that it will print every single number because we have 5 elements here. So if the number is 1, its square root is 1. If the number is 2, its square root is 1.412. So this with one single command, and because the input is an array, whether it is a vector or it is a matrix, the fprintf command will keep repeating until all elements have been displayed. Another function of the fprintf command is that we can save the output to a file. So let's take a look at this example script here. This script which fprintf is used to write output to files. So we have here a conversion from mile per hour to kilometer per hour. So here is the velocity in mile per hour. We have 10 until 100 with increment of 10. And then we have the conversion here, velocity in kilometer per hour, that is equal to the velocity in miles per hour, this variable that we have defined earlier, multiplied with 1.609. And then we make an array out of these two variables. So we have table 1 here, TBL1 is equal to velocity in miles per hour and also velocity in kilometer per hour. So in order for us to write this table into a file, it requires 3 steps by using fprintf command. The first one is to open a file using fopen command. So this is opening a file. FID means the file identifier. So we have to type in FID equals to fopen. Then we type in the name of the file that we want to create. So here we type in vmph to vkm.txt within apostrophe. So this is the name of the file that will be created by MATLAB and will be placed in our current folder. And then comma here, after the comma, here is the permission code. So W here stands for write, so which means that we allow MATLAB to write into this text file. So basically this will open a text file named vmph to vkm. There's a few more permission codes. For example, if we change this to R, then it will be read only. This is the default permission, but in this case we want it to be able to write. We want MATLAB to be able to write into the file, so we change this to W. We can also type in A. For example, we have already a few data written into a file, so we want the new output from MATLAB to be appended below the existing data, so we put A here for append. And then there's a few more permission code that you can refer in the lecture notes. So in this case, we are going to stick with W. And then we type in what we want to print in the file. So now we have fprintf command, and then before we type in the text or the strings that we want to print, we have to type in FID, file identification. So we identify that this file, this will be written in the files that we have opened here. So FID comma, then comes the strings. So the first line we want to type in velocity conversion table, and then we put in \n to have two spaces, two empty lines. Then this will be followed by the next line. We print also fprintf FID. This will write in the same file as well. So we type in mile per hour and then kilometer per hour, and then we type in \n to go to the next line. So notice the space here is for MATLAB to write the table nicely. You will see the output after this, and then finally comes the data. So fprintf here FID again, and then we type in %8 8 digits with 2 decimal places. The same goes for here, 8 digits, 2 decimal places, comma, we put here TBL. There's only one variable here because TBL here comprises of 2 variables within an array, so we don't need to type in VMPH, VKMH, but instead we type in TBL1 here. And then the last step is to close the file that we have opened. So the first step is to open a file. File identifier equals to fopen, and then we type in the name of the file, .txt, comma, and the permission to write, we type in W, and then here is whatever we want to display in the file. We want MATLAB to type in the file, and then after the fprintf command, we need to close the file. So fclose in the bracket FID, we close the original file that has been opened here. Let's see what happens when we run this script. So I'm going to press run here, and you will notice that there is a new file being created by MATLAB in our current folder. So when we double click on this file, we see it has been printed according to what we have typed in previously. So velocity conversion table, this refers to the first line, line 10 here, the first line of fprintf command, and we see here 2 empty spaces we have created, \n. So we have here \n will go to here, another \n will go to the line number 3, and then we type in mile per hour and kilometer per hour. This will be displayed here, mile per hour, kilometer per hour, and \n, the next output will go in line number 4, and this is our output from the calculation. So that is how you create a file from MATLAB calculation using the fprintf command.